Hi, everyone. My name is Amar Kapadia. I'm a co-founder at Aarna Networks. And today's talk is about orchestrating and managing private 5G, so automating private 5G network functions and the underlying infrastructure with Nephio. So in terms of the agenda, we'll talk about private 5G orchestration and management problem. Then we'll talk about how we can solve this problem with Nephio. And finally, we'll go through a demo. So I'll try to finish in maybe 15 minutes, so we have enough time for the demo. And then how to get involved. So private 5G orchestration and management problem. So the first problem for orchestration and management in private 5G is to support multiple vendors. So the whole idea is you can choose the best-in-class RAN, the best-in-class 5G core, and other components. The other components can be servers, they can be a Kubernetes distribution, they could be a backhaul switch, they could be edge computing application, CPE. There's just many, many components that go to make up a private 5G. Second is cost. With a multi-vendor environment, you do get cost advantages. And third is the ability to optimize the network to match requirements. So by switching out the RAN or the core, you may be able to adapt better to customers that need mobility or customers that need location services or latency. So that's the first requirement, to support heterogeneous multi-vendor components to get functionality, feature, and cost benefits. And the next is to have a single pane of glass across all your private 5G components. So a lot of these components have wonderful EMS systems, element management systems that come with it, wonderful GUIs. But the network manager, whether it's the enterprise or if it's the MSP, they don't want to have 7 or 8 GUIs. They want to have one GUI, single pane of glass, to manage the whole network. Finally, single pane of glass across all your private 5G networks. So if you are an MSP or a large enterprise managing tens or hundreds of networks, again, you don't want 100 dashboards. You want one single pane of glass. And so we need the following. We need an orchestration and management software that goes across infrastructure, network services, and applications. We need to be able to manage CNFs, VNFs, PNFs, and cloud-native applications. We need an inventory system to track all these elements. We need multi-tenancy. We need to be able to monitor the entire environment, whether it's infrastructure, Kubernetes layer, or the network functions or applications, and visualize them. That's what you can call it open loop automation, visualize it, use it for ticketing, et cetera, or use it for closed loop automation. So this is automatically orchestrating or automatically performing a lifecycle management action without involving a human being. And finally, you need easy-to-use APIs and GUIs. So there are current solutions. You can use a telco MANO, or you can use just plain Kubernetes, but we feel both have some shortcomings. Telco MANO, the ease of use needed by an enterprise is typically not there. They're meant for telco users, nor is there a customized private 5G GUI. They're not built for edge scale. The cloud-native functionality is coming, but it's still limited. And it's not designed to handle the underlying infrastructure typically. Kubernetes is great, but it lacks GitOps, scale, and an easy way to convert business intent to technical intent. It lacks monitoring and closed-loop automation capabilities, lacks private 5G-centric GUI. So we feel that the Linux Foundation networking projects are wonderful to solve this problem that I just outlined. The core orchestration and management project that we're using is Nephio. And if you saw my previous slides, and if you're familiar with Nephio, you know I set it up, for Nephio. So we really think that Nephio is an excellent solution. It's Kubernetes-based. It's intent-driven, declarative, scales tremendously. It has a GitOps baked into it. So we really like Nephio. For data collection, open loop and closed loop automation, we're using collectors with a Kafka bus that can go to Grafana for visualization. And for closed loop, we're using CNCF OPA. It's an open policy agent project. It's a very rich, versatile policy agent. And the policy agent, OPA, automatically drives an orchestration or a lifecycle management action. We have a thin workflow engine on top. It's Camunda-based. It originally came from ONAP SO. And increasingly, we feel that Nephio can handle all the dependencies, et cetera. So the job of a workflow manager is minimized. But there are some exceptional situations where you do need a workflow engine, so we have that. For inventory, we use a project from ONAP called ANAI, Active and Available Inventory. It's a graph database using Janus Graph. And then on top, we have APIs and GUI. The APIs, we have REST APIs, native APIs. We also have a Sol5 interface to interface with traditional OSS BSS systems, Python SDK, and a private 5G-centric GUI. So the idea is we have the software that I just showed you. We have packages as our own distribution. We call it AMCOP, Aarna Networks Multi-Cluster Orchestration Platform. So that's the Nephio cloud. On the top right is the Nephio central cloud. And the cloud at the bottom is the edge cloud, which is implementing the private 5G network. So the RAN, the core, potentially a firewall is running on that cluster. This is just one reference architecture. The beauty of this approach is that you can change the reference architecture. Let's say you only want the CU. You only want the UPF at the edge, and you want the rest of the core in a central site. That can be done. If you want a centralized CU, you can do that as well. So this is a very simple reference architecture where everything is running at the edge site. But you don't have to. You can move things around, change things just by changing the intent. So that's the beauty. And we are not showing, this is a simplified diagram. We are not showing the edge computing application. Our view is that private 5G goes hand in hand with an edge computing application. So you need that, whether it's computer vision or some other application. Then there are other things you need as well. You need potentially a CPE. You might need to have UEs that need to be configured, like AR, VR goggles, et cetera, Grandmaster. So it's not showing everything. It's just showing some of the main components. So how do we solve it using Nephio? So I know there have been many other sessions on Nephio, so I'm not going to kind of use this session as a Nephio primer. But I'll just flash some quick slides in case this is the first time you're looking at Nephio. So first of all, Nephio is a Kubernetes-based framework. So it's really just Kubernetes. And the job is to automate the network functions and the underlying infrastructure that supports these functions. So it's both infra and network functions. I think the mission statement could be expanded a little bit. It also handles edge computing applications. So it's not just network functions and the infra. So I feel this mission statement is limiting what Nephio actually can do. And it's intent-based, so you provide a declarative intent, a business intent, and Nephio has a pipeline that'll convert it to a technical intent and apply it to an edge site. Cloud to edge, initial configurations for the network functions, and deliver those configurations to the right clusters to get the network up and running. Again, Nephio is not just for day 0, it's for day 1, day 2 as well. So ongoing configurations, lifecycle management can all be done. So this, this is quite wordy. Maybe I'll skip it in interest of time. Again, if you've attended other Nephio sessions, you know about the 3 swim lanes. One lane is to orchestrate and configure and manage the infrastructure. That infrastructure can be cloud-based, so it can be API-driven. So it can be spinning up VMs, it can be spinning up bare metal as a service, or it can be bare metal. So in the work we have done, we spin up bare metal servers using Redfish APIs using Nephio. So that's the first swim lane. The second swim lane is orchestration of workloads. Again, I feel it should not be limited to just network functions. It should be network functions and applications, cloud-native applications. So that's the second swim lane. You orchestrate that on Kubernetes. It doesn't have to be, but this shows orchestration on Kubernetes. And the third swim lane is configuration management over time, which is shown here. And again, I'm sort of repeating myself, but it can be applied to applications as well. And the whole approach is to use Kubernetes resource, so CRDs, custom resource definitions, and APIs based on that. The network functions and applications and infrastructures can all be heterogeneous. So the point I made about heterogeneity is natively supported here. It can be from any vendor. And you have operators that translate the intent to actual configuration that the device, network function, application understands. And this all 3 swim lanes are wrapped in a GitOps approach, using a GitOps approach that cuts across all 3 layers. So this shows the 3 components of Nephio. This is, I think, another beauty of Nephio. If you're used to ONAP, 24, 30 projects, when I first heard that, I felt really good that this is a comprehensive project. But then I realized that only lends to complexity and very difficult to use. So here there are only 3 projects. There's Kubernetes. There's something called Porch, which does package management, and it's a wrapper around GitOps. And there is something called config sync. So the intent is expressed through a package called KPT, and that package is managed by Porch and revision controlled and all of that good stuff through Porch. Then you have Kubernetes and all the controllers that go with it. There are some that Nephio works on, some that the user can build. And then you have config sync that takes those configurations and pulls them onto the edge site. So config sync is on the edge site, and it pulls the configurations from the Nephio cluster to the edge site. So that's how you get scalability. So you get GitOps, you get scalability, you get business intent being translated to technical intent all through this approach. So the package variant controller is a Nephio controller. What it does is it grabs the intent from a repo, and then it hydrates or mutates it, and then drops it into the repo for the edge site. And how is that hydration mutation done? It's done through a variety of KPT functions and associated controllers. And you have a bunch of controllers like IPAM or whatever that can populate that intent into a technical intent, and then config sync takes it into the edge cluster. So that's really how the pipeline is built, and the pipeline converts the business intent to a technical intent. And that's kind of the Nephio approach. So config injection, this is more static. You inject the configuration into a generic intent, and you customize it for the specific edge site. And that may be based on the attributes of the edge site, et cetera. Package specialization, this is done more static, more dynamic. So this is like the IPAM one I showed you, where you're dynamically changing the configurations for the intent. And finally, condition choreography. This has to do with a lot of dependency management. So all of the dependency handling is done natively through Kubernetes and Nephio. You don't need to create workflows to manage dependencies. And that's done by this condition choreography, which is constantly checking if all of the conditions are true. If not, it keeps reconciling. And when everything is true, then the pipeline is complete, and the intent is ready to be consumed by the edge site. This shows a visual way of what we just discussed. So you have blueprints at the top in the blue-colored repo, and that's being taken by what we just said, the package variant controller. And the package variant controller is injecting the configurations, customizing the package based on the pipeline that was described, and then pushing it to edge sites. Here they're showing a couple of edge sites for the UPF and one edge site at the bottom for RAN and core. But it could be anything. It could be any topology that you want. So what we have done for the private 5G intent is we are using this experimental topology controller. So you describe the whole topology, and the topology controller fans it out to package variant controllers. And the very simple business intent. So on the left, you're seeing we have very simple intent for RAN, very simple intent for core. And the reason it needs to be simple is enterprise customers are not able to deal with 1,000 RAN parameters, right? They have no idea. It needs to be boiled down to like 6. And those 6 items then get hydrated and mutated to the 1,000 parameters that need to be used to configure the RAN, for example. So, and this mechanism, the Nephio mechanism that we just discussed, generates the network functions dynamically for the network functions based on the contextual information of the deployment environment, and there is continuous reconciliation of the intent. So this is another very nice feature, continuous reconciliation, so you don't get drift, and the same reconciliation procedure can be used for day 1, day 2. So left-hand side is the simple intent, right-hand side are specific configurations for each network function. This is further expanding what we just discussed. So we are showing the intent on the left, and then it's going into a repo. The package variant controller is then running it through a pipeline, mutating it, hydrating it, and then pushing it to a specific repo for an edge site. Config sync is pulling it from the edge site and applying it locally. And the pipeline is made up of KPT functions and Kubernetes controllers or operators. And then there's a specific thing called an approver controller as well to sort of approve. It's kind of self-explanatory. So with that, I'll switch over to the demo. Yeah, so the demo is doing exactly what we just said. The network designer is providing a 5G topology intent, and that topology intent gets fanned out to different package variant controllers, and each one is dealing with a different network function, and using config sync, it gets applied to the edge site. It goes into a specific repo, and then the edge site pulls it. So I'll just play the demo. Do I need to do something for the audio? Excuse me, do we need to do something for the audio? Yeah, I plugged in the audio plug. Yeah, I put in an audio plug right here.
Okay, so then we'll make sure that's in.
Just check your audio settings, see if you're setting it to
Oh,
phones or
okay.
the settings or audio. You should see sound. Scroll down and see sound.
My mouse is misbehaving when this is connected. Sound.
Yeah, send it with headphones and stuff, HDMI.
Yeah,
External headset, right?
you should be fine now.
Okay, that's okay. I'll try to speak through it as best as I can. So we'll onboard 3 clusters onto AMCOP, core, regional, and edge clusters. We'll create the private 5G app catalog by onboarding the open air interface core and RAN. We'll create the topology intents. We'll orchestrate OAI RAN to regional and edge clusters. And then we'll orchestrate the 5G core to core and edge clusters. And then we'll do deployment and end-to-end sort of path validation. So we've already looked at this. So we have blueprints that are in a repo. And then using sort of the package variant topology controller, package variant controller, we create the technical intent that is created for 3 clusters, the edge cluster, core cluster, and the regional cluster. And these clusters are running Kubernetes they're kind clusters, and they're pulling the configuration. So now it's just showing, logging in to the private 5G GUI. It's creating tenants. So it's a multi-tenant system. Now it's creating the 3 edge sites that we talked about. Edge, yeah, so this is all the cluster. Let me see if I can fast forward a little bit. So now we're in the app catalog onboarding OAI, RAN, and core. So yeah, this one is showing OAI core. So once it's onboarded, it's available to Nephio. So again, let me fast forward a little bit. So now we are onboarding the RAN, same thing. So now we are creating the topology. So an OAI topology, a new topology. So with a RAN, can define which cluster we want the RAN to be on, regional cluster. And I think let me just speed ahead. So then the deployment happened. So I skipped some of the steps. There were some lightweight configuration screens, and that went through, and Nephio orchestrated all of that. And the rest of the steps are basically just verifying that all of that happened. So the slides have been uploaded, so you guys can see the demo later. And in terms of getting involved, if this work is interesting, we would like to do more of this in Nephio. So please contact me or Sandeep. And we are also happy to work in the 5G Super Blueprint if there's sufficient interest. So with that, I'd like to stop and maybe take a question or so. Yes, yes, yes. 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 That's what we use ANI for. Yeah. Yeah.
So there's one service or multiple resources? The three clusters, you have one end-to-end service?
One end-to-end service across 3 clusters. Yeah. Yeah. All right. Thank you all.